finish your assignment also. Okay, assignment and submit it in on time. Okay. So now we will be moving to the yes. So now we will be moving to the next lecture of the third unit. Okay. So your next lecture will be in last class we have seen about gaseous breakdown. Okay. So breakdown in gas. So in the breakdown in gas, I have just given an overview regarding Townsend theory. Okay, the Townsend theory I will be covering in the later part. Okay, with respect to derivation. So now we will be moving on to the next breakdown. It is nothing but your vacuum breakdown. Okay, so vacuum breakdown. So in this you will be seeing about particle exchange mechanism, followed by your field emission theory, followed by a cathode heating mechanism, followed by your anode heating mechanism, and then it is your clump theory. So we'll be seeing these topics today. Okay. Yeah, we have started with. We can start from vacuum. Okay. So first you have to know what is vacuum. Okay. So vacuum is nothing but it's a place. Okay. It's a place wherein there is your atmosphere. That is, the pressure will be very well below that of the atmospheric pressure. Okay. So the value will be less than the atmospheric pressure. If then you can say that the system to be or the place to be vacuum. Okay. So in general, the amount of air in the vacuum space will be very minimum. Okay. So vacuum is also is related to a medium. Okay. But the thing is that your pressure will be very low and the amount of air will be very less in the vacuum place. So in your school level, you might have studied in different experiments in physics and chemistry. That is, so you'll be carrying out some of the experiments in vacuum. So in like that, you might be assuming some conditions. Okay. So under that conditions, what you'll be doing is you'll be taking a glass system or a glass box. In the glass box, you will be taking out the each and every amount of air from the glass box. So if you are taking like that means what suddenly happen is that the pressure inside the glass box will be increases exponentially. Okay, so that's what vacuum is. Okay, so if they have given a range of for high vacuum, very high vacuum, and ultra high vacuum. So it is given in unit of torque, which is nothing but one of the unit of pressure. Okay. So next, what they are saying is for electrical insulation purpose, the range of vacuum generally used is high vacuum. So for insulation purpose, the vacuum will be of they'll be using this kind of uh, range, that is high vacuum. If the vacuum is high means at this range there won't be any kind of conduction. Okay, so that's what here they're saying. So we have seen what is vacuum. So now we'll be getting with vacuum breakdown. Okay, so this vacuum breakdown consists of some theories. Okay, it is comprises of some theories. So what are those means? First is the particle exchange mechanism. Okay, particle exchange mechanism. Second one is the field emission theory. In this field emission theory, it is of two types. One is your anode heating mechanism. Second one is your cathode heating mechanism, and third one is your Clump theory. Okay? Third one is your Clump theory. So these are the three things we will be seeing today. Okay. So moving on, first is the particle exchange mechanism. So these are all very simple. These three theories will be a kind of story, and in this, some of the theories will be similar also. Okay. So what is particle exchange mechanism? So in all the these three theories, what they'll be doing is they'll be having two electrodes. One is your cathode, followed by your anode, which will be kept in a vacuum environment, similar to that of your, I said no, on glass box. Similar to that, you will be taking a glass box. In the glass box, you will be keeping two electrodes, cathode and anode. Okay, and you will be doing this experiment. Okay, so the pressure inside that vacuum will be very high. Okay? It will be of high. We have seen it. So in this, what they're saying is, in this mechanism, it is assumed that a charged particle would be emitted from one electrode. Okay. So this you already know. When there are two electrodes, if one electrode is subjected to electric field, means surely there will be liberation of charges. Okay, so that's what they are saying. So the breakdown will occur if the coefficient of production of secondary electrons exceeds the unity. So they have given some coefficients. Okay, what are these coefficients? Means these coefficients will be belonging to the similar to that of your what you can say, the coefficients which are used for used during the liberation of electrons. Okay, mainly it will be, can see these kind of coefficients in avalanche breakdown. Okay, so it is similar to that of the thing what we have seen in your gaseous breakdown. That is, if the one electron occurs, it's similar to the ionization process. If one electron gets ionized, there will be secondary ionization. So similar to that, this happens. Okay, so the condition is that the breakdown when it occurs means these coefficients of production of secondary electrons. Okay, so if there are formation of secondary electron means these coefficients must be greater than 1. Okay, accordingly, this theory was modified to allow for presence of negative ions, and the criterion for breakdown then becomes. So here, if we are considering for the negative ions means, we are omitting the positive ions, and if we are taking with respect to the negative ions means, so you will be getting out the condition like this: AB plus EF greater than 1. Okay. So it is just modified from this to this. They have been modified. Okay. So now moving on. So this is the particle exchange mechanism. Next we will be seeing about the anode heating mechanism. Okay, so it is one of the, nothing but it is one of the, what you can say, field emission theory. Okay, so what they are saying is that due to the presence of micro projections, so micro projections on cathode. Okay, so what happens is in general is that electrons are produced due to field emission. Okay, which will travel towards the anode, and bombardment takes place. Okay. So there might be some kind of projection over your cathode due to some kind of dust or dampness in the air, like that. There might be any kind of projections in your cathode. Due to this, what happened is that when it is applied to the electric field, the might be possible of charges to move from these projected areas towards the anode, and it gets accumulated at your anode. Okay, it gets accumulated at your anode. So that's what they're saying. This will cause a local rise in temperature and release gases and vapors into vacuum gap. Okay, so due to the heating over here, it increases the temperature and releases gas vapors into the vacuum gap. Okay, these electrons ionize the atoms of the gas. So that's what they're saying. So after the liberation of electrons, this again causes ionization of around them. Okay, and produce positive ions. These positive ions arrive at the cathode, increases the primary electron emission. Okay, due to space charge formation. So what is space charge? You just Google it and see. Okay, you might be getting the answer. Okay, so if I'm going into this topic of phase charge means it will be very very uh, elaborate to explain. Okay, so otherwise I will be giving a separate topic regarding this phase charge. Okay, so but you have to know space charge is generally nothing but a particular amount of charges which gets accumulated within a area. Okay, so and produce secondary electrons by bombarding the surface. Okay, so first what happened is that here similar to your secondary ionization in the gaseous breakdown, here also there will be occurrence of two breakdowns. Okay, first what happens is that these gets liberated and it again ionizes with the gas, and those positive particles will again get attracted towards this cathode to again uh, develop a secondary bombardment. Okay, secondary bombardment. So this process continues, okay, until a sufficient number of electrons are produced to give rise to breakdown. Okay, so next is the cathode heating mechanism. So here what they'll be saying is due to the presence of sharp points on the cathode surface. Okay, so what happens is that when increase in current causes resistive heating at the tip of a sharp point, okay, then a critical current density is reached. Okay, the tip melts and explodes, thus initiating a vacuum discharge. So in general, in the all the three categories, what you have to see is that there has to be, in general, the vacuum doesn't conduct any kind of electricity through it. A vacuum is a very good insulator, so it doesn't allow any kind of charges to pass through it. So what happens is that you have to develop the charges within this vacuum environment. Okay, so that's what it means. Within this vacuum environment, if you are making some charges, means the discharge or the breakdown occurs. Okay, that's what they will be saying in all the three mechanisms. Okay, so here what they are saying is increase in the current. Okay, the increasing the electric field. So in current refers to the electric field. What happens is uh, causes heating. This you already know. So if there's a excess amount of current flow, means the resistance heating is possible. Okay. So this cathode will be concentrated with excess amount of heat to produce a vapor cloud. Okay. So from this, the positive ions try to be attracting, and a small discharge will be formed. Okay. So next is the clump theory. So this theory is based upon some assumptions. Okay, so the first assumption is that the loosely bound particle clump exists on one of the electrodes. So clump is nothing but what you can say a group of unwanted particles. You can say like dust. Okay, like dust we can take it out, or some moisture kind of things. Okay, so it forms a clump. So this clump will be get attached to the surface of the electrode. Okay, so it will be there, and it is exposed to the vacuum medium, and there is no discharge between these two. Okay, so when the high voltage or the electric field is applied to the electrode, okay, the particle gets charged. Okay, the particles in the clump get charged. Okay, and what happens if it is charged means it gets discharged, okay, or detached from this surface. Okay, and it is an accelerator across this gap. So this is what it is, this diagram. Okay, the breakdown occurs due to discharge in the vapor or gas. After the discharge, okay, how this breakdown or the discharge between cathode and anode occurs means, okay, uh, due to the impact of the particle at the target electrode. Okay, so here they have given a voltage expression. So V equal to C dash. Okay, so in case of parallel plane electrodes, the electric field intensity you already know E equal to B by D. So where D is the distance between them. So the generalized criteria for breakdown. So this is the breakdown criteria. So what happens is that this will be subjected to a very high electric field, and the clump particle comes out of the surface of the electrode. So after this gets ionized. This clump particles gets ionized, and then it moves to the next kind of electrode anode. So during that time, there has to be some amount of voltage to cause the breakdown. So that criterion is given by V equal to CD square root of CE. Okay. So next is the glow discharge. Okay. So glow discharge means a discharge which is accompanied by your very high light, okay, or a glow. So this glow is discharges the characterized by diffuse luminous glow. Okay. So the color of the glow discharge depends upon the cathode material and the gas used. So for a normal glow, this glow discharge, how occurs means during a normal discharge there will be some kind of glow which is visible to our eyes. Okay, the glow discharge covers the cathode partly, and the space between the cathode and the anode will have intermediate dark and bright region. Okay, so this will you have studied with respect to your physics, the light bands and your dark bands. So the same concept will be coming out. So what they are saying is the glow discharge covers the cathode partly. Cathode will be covered, and the space between the cathode and anode will be having intermediate dark and bright regions. Okay. So like similar to that of a light bands they'll be saying. Okay. So abnormal glow. If the current in the normal glow is increased such that the discharge covers the entire cathode surface. Okay. So this arc discharge is the main principle where they'll be using is they'll be using in your welding. Okay. They'll be using in the welding. So cutting of metals. Okay. So mainly in high power applications they'll be using. So high power applications like welding you can see it out. Okay. So next is the this is the discharge graph. Okay, this is the discharge graph. Generally, what happens is that so you will be applying. This is the voltage VI graph. Okay, so your voltage is on your y-axis, your current is on your x-axis. So you will be increasing the voltage. Okay, you'll be increasing the voltage. Your current will also will be directly increasing. So during that time, so you'll be getting out a graph which indicates the different modes of discharge in a vacuum breakdown. So this is what happens in a vacuum breakdown. So first what happens is that there will be a small amount of discharge. Okay. So after that the transition will be from dark to glow discharge. The glow discharge will be happening. So from C to D you will be having the glow discharge. So still if you are increasing the current value, okay, and decreasing the applied voltage means what happens is that goes to the abnormal glow wherein your current will also will be increased, your applied voltage will also be increased. Okay. So generally what they'll be doing is they'll be having a very low voltage in your welding concept and all. In your welding and all, what they'll be doing is they have very low voltage but the current will be very high. So this contribute to your arc discharge. Okay. This contribute to your arc discharge, and hence due to the high heating, high flow of current, what happens is that the lead in the welding gets melted. Okay, so you have to be clear for welding. They won't be using high voltage. Indeed, they'll be using high voltage, but the basic principle is they will be making use of the current. Okay, they will be allowing the very high current to flow through it, and that current will be making the lead to melt with the other metal. Okay? So we have to have such things. Okay. So from this, the possible question is, you can expect what are the different mechanism of vacuum breakdown. Okay, so how the vacuum breakdown occurs. Okay, so followed by the particle exchange mechanism from the principle of anode heating and cathode heating, then can expect. So regarding this, I'll be giving the detailed notes also. Okay, I'll be putting the detailed notes so you can see it. So the notes I'll be putting after completing the entire topic. Okay. Um, so with this lecture gets over. Okay.